Hey everybody, thank you for clicking on my video. I really appreciate it. If you haven't subscribed, please consider doing so. So for those that are new, what I do on this channel is I take electronic projects from old electronic magazines and then I bring them to life. I build them and then I show you the final completed project. That's what I do. I'm hoping that interests you. And as usual, I always tell people, I'm not a genius. In fact, I'm just a technician at the very most. So if you got any complex questions to this project, I'll try my best, but you might have the wrong channel and the wrong person. However, there are lots of people that comment and sometimes give a great explanation of what's going on if I can't understand it. So we're going to have a lot of fun this week because we're going to go back to Elektor. Elektor, December 1976. My God, what were you doing in 1976? I was 10 years old. And yeah, and it kind of goes, the reason I wanted to do this project is because I made another video about 3 or 4 videos ago, maybe 5 videos ago, and it was a musical processor. And I couldn't get the phasing and the vibrato to work. Well, I found another circuit from Elektor, and it kind of, well, in fact, there is a circuit that'll give us phasing and vibrato. Now, I'm not so much, too interested in the actual musical aspect of it. This is more of a learning experience for me, and I couldn't get it going on the previous project, so I'm hoping I can get it going on this project. And I guess if you're watching this video, that means it actually worked. So, I'm in a way, I'm selfish. I want to see if I can get this thing to work, but hopefully maybe you can get something out of it too. So the main chips we're using in this project is the TDA1022, same chip that I used on that music processor, and it didn't work. So I'm curious to see if it works on this project. The chip is it's called an analog shift register or a bucket brigade memory, and it's going to give us a delay. And I'm showing you the block diagram of that chip right now, and as you can see, it's just a bunch of FETs and capacitors, and I think there's 512 of them. So I think from what I read in the article, it might give us a half a second delay at the most, I think. So that's what's going to give us our phasing and our vibrato, maybe. I'm not too sure about the vibrato. But the other chip we're going to use that is unique and I never knew existed was the XR2207. Yes, not the 2206, the 2207. And it turns out this chip is a lot simpler than the 2206. So the 2207 is essentially a VCO, right? Voltage controlled oscillator. But it does have triangle sine wave out and also square wave out. It does not have the sine wave output. You would have thought maybe the 2207 would probably be like the older one, and the 2206 the better and newer one, but it doesn't work out that way. Anyway, so I'm showing you the block diagram, and there are some current switches, which I'm not too familiar on what the function of those is. Now, I know looking at my schematic, we're using R3 from pin 6. So that's the one we're using. So maybe when we get the project built, I'll go through it with the scope and maybe I can learn what function that does. And the other chip is a 741 chip, and that's going to it's a low pass filter, so we're going to get rid of all the clock signals finally at the output of the TDA1022, and we'll be left with I guess our original signal but delayed. So that's the chip. So let's maybe move on to some other stuff. Okay, so for funsies, I'm showing you what the author's version is from the magazine from 1976, and there's an inside picture that I'm showing you right now, and here's another inside picture of the actual device they came up with. Hopefully I can get something close to that. And right now I'm showing you the board, the original board from the magazine. So remember, I electronically cut out the board design from the scanned in magazine. So the quality is not that great. And what I do is I put it into a photo editing program called GIMP, and then I make it I make the traces better and I increase the contrast, etc., etc. And this is what I'm showing you now. So in this case, the actual original wasn't too bad, but the final version is much better. So I've got a good contrast for this board, so that'll help me out with the etching process, I hope. Okay, so let's move on to the schematic. And I don't know if I have this right. I've just got a high-level overview of what's happening. So, and remember, we're having fun here. I'm not, an expert in any of this stuff. I'm just learning as I go. So be kind in the comments. But what reading the article, so what I've gathered is, if you look at the right-hand side, you see the T4 and T5, I think it is. And that is our phase shift oscillator. So in order to get both effects going, we're going to need a whole bunch of stuff, right? And we start off with that phase shift oscillator. And it's variable by that trimmer pot, P4. And with the three ranges, we're going to get 0.3 hertz to 1.3 hertz. And the next setting on that switch 3 is 0.9 hertz to 2.8 hertz. And then the final switch setting is 2 hertz to 6.5 hertz. And what happens is that's fed into, it's hard to see here, T6, I think it is, on the kind of bottom right-ish a little bit. That amplifies the circuit. And then that actual output then modulates the XR2207 at the very bottom. And unfortunately, the 2207 only gives, a positive output, doesn't give us the negative and positive. But if we feed it into that 7474 chip, the flip-flop, we can get the inverse phase signals, and we need, or clock, because we need that. That's what the TDA1022 is looking for. But before we send it off to the 1022, according to the article, the 1022 has a lot of capacitors, and it has a low input impedance. So we can't just feed the 7474 to it. We got to go through, I guess it's impedance matching, or a kind of a driver, and that's what T1 and T2 apparently is. Could be wrong. But then, like I said, the output of those two transistors, which is our inverted clock signal, will feed the 1022. And to the left of the 1022 is our input, of course, right? So whatever we're going to put into this, like a steady tone or guitar or an organ, whatever. And it goes through the 1022, and that's where we get the delay, and we got to get rid of the clock frequencies too. And like I said earlier, that's what the 741 does. And then we finally get our output. Again, it's a high-level overview. Hopefully I got it right, but I'll definitely learn a lot more when I get this thing built and I can scope it out. It'll be wonderful. So I'm looking forward to it. All right, so let's get on with the build. I know I've been yapping for quite a bit, and get this thing built. Okay, so I've got all of the parts, including the IC chips. I've got a board ready. And what I'm going to do for the power supply, so the power supply is not built on the main board. So I have to build an external one. And what I found is a generic power supply circuit. So I've got the, the traces, and I've got the top component mapping, and then a schematic. So I'm going to make a whole bunch of these, actually. I might make 4 to 5 of them, just for future projects. And of course, I'll use one for this project here. So that's what we're going to do. Let me get started. I'll bring you in on a time lapse, and let's get going. Okay, so it's a day and a half later. Okay, yes, I had a doctor's appointment. But anyway, I'm having a heck of a time with these boards. First of all, I didn't have them mirrored correctly. So I etched the boards, and they're garbage, right? So anyway, I corrected that problem, and then I etched them again, and the quality was horrible. So this one here is the hammer mill paper, which I think the last project I did, I used the hammer mill paper, and it turned out okay. So there might be a lot of variables, the etchant is getting older maybe. But I noticed here, let me actually put this one up against the light. You can see the sides are much better, but the center is horrible. So I'm thinking that might have something to do with the laminator, right, where it's not getting the center. So I guess maybe next time I could experiment and use an iron, a regular iron, and then do the center portion, get it really hot. But what I did instead is I went to the Staples paper, which is this one here, and this one turned out pretty good. I mean, I'm not going to complain about that. There's a couple, there's a broken trace somewhere here. I can't, oh, there it is right there. But much better in the center. So that's the glossy paper, the Staples glossy paper. I think what I'm going to do is I'll go to Staples and I want to try some other paper that I've got my eyes on, because the beauty of this hammer mill paper is it'll just come off. You put it in the water and it floats off. That's what I want. But I can't get that with the glossy paper. It's you have to use your thumb to get the paper off. I mean, it takes a little bit of time. Not a lot, but it'd be nice if I can get something simpler. That'll be next time. All right, so let me get these boards drilled and I'll bring you back in. Alright, so as you can see, it looks to be done. I got to put the chips in, but I first want to check the power supplies. Speaking of power supplies, this is the standardized power supply that I got from a magazine. Don't know which one, but anyway, it's going to be a well-used power supply. I made, I think, 6 more boards, I'm pretty sure. In any event, we're using it for this particular project, so that's what this is all about. And a couple of interesting things going on with this particular design. Now, I know this is kind of an early article or an early magazine because there are some funny things going on. Elektor is an awesome magazine. The projects are very, very well laid out, but this one's, I think maybe because it was earlier, it just had a couple of small things going on. And the main one being this chip here. This is IC2. It's an 8-pin dip. However, and it should be that 741 goes in there. However, the traces are actually made for 14-pin. So don't know what's going on. But anyway, that's a big flag. So change that. And you'll notice that on some of these switches here, maybe not, you'll see a capacitor there. And in fact, this one has a resistor too on the other end. So when you look at the schematic, oh, sorry about the shaking, you'll see things like, well, this is a really tricky one here. So this is our rotary switch, switch 1, whatever, A, B, and C. But we also have this dual ganged 100K pot also in the mix. So, you know, you got to go off of this pole here and onto the center of these, etc. So there's a lot of that going on. And just quickly, I know your time is precious, so I don't want to waste it. Yeah, so here's another one too, I think, right? Where you have this switch here. Oh, these are external inputs. So you can actually bypass the generated one here with separate inputs. So I actually added these to my circuit. Anyway, so there's a lot going on with the circuit. So if you are building it, just be careful. Really read the schematic and understand it before you're going further. Now, I hope this thing works for me. That's my biggest concern. So what I'm going to do now is I'm going to get I'm going to hook this power supply up to the board without the chips and measure the voltages, and I'll bring it back. Okay, good news for me. I got the circuit to work. So there was a few problems. There were 2 traces on the back that were shorted out to other traces. So the actual, I guess, pad was very close to another trace, let's say. And I didn't leave it in long enough, I suppose, for it to etch properly. In any event, I found those, fixed it. And there's this wire here. So the end of that resistor there, it goes nowhere. But so I had to actually bring it to where it belongs. There's a small botch wire there. Anyway, it works. So I'm really happy about that. Let me just give you a demo. Turn the power on. I'm using, well, you can't see it here. Maybe I'll go up here a little bit. So I'm using this sweep generator that I built a while back, and this is an amplifier here, just a 3-watt amplifier. And then of course I got my board, and there's the power supply. Let me just turn it on. You can kind of hear like a phaser or echo reverb. It's working. Okay, so what I'm going to do next is I'm going to just show you some of the signals, right? So I'll show you the clock and the 2-phase clock inputs to the actual TDA1022, etc., etc. Just really quick. There'll be like short cuts, clips, and move on to the next one, and then finally put it in a case and demonstrate it properly. All right, so what I wanted to do is just quickly go over some of the main signal points of the circuit. So let's start with the low frequency oscillator, and that's what gives the vibrato, and that's what I'm showing you, the section of the schematic I'm showing you right now. So I'm going to put a probe on the emitter of the bottom transistor. So I'm showing you the output of the vibrato oscillator. This is the 1.3 hertz, and the next range is 2.8 hertz, and the third range is 6.5 hertz. And each one of those ranges are adjustable. Okay, let's move on to the next point. All right, so the next test point is going to be pin 13 of the XR2207. All right, so I'm showing you the output of the XR2207 now, and you can kind of see the, well, in fact, you can clearly see the vibrato effect. So I've got it, I think, on the mid-range, so that could be about 2.5 hertz or something like that. So it's almost like it's modulating the actual digital signal. And just for funsies, I'll go on pin 14, and that's the triangle wave. So just for a refresher, the 2207 can do square wave and triangle wave. It can't do a sine wave. Anyway, let's move on to the next test point. All right, so the next test point is going to be the clocks going into the TDA1022. So they have to be 180 degrees out of phase, and that's what we got. So let me show you on the scope. Okay, so I'm showing you the 2 input clock signals to the TDA1022. So they clearly are 180 degrees out of phase. And they're being fed by transistors 1 and 2. So as mentioned earlier, this chip, the TDA1022, has got a lot of little capacitors in there. And it needs to be driven a little bit harder. And that's what T1 and T2 does. All right, let's move on to another signal. All right, so now we're going to look at the input of the TDA1022, pin number 5. All right, so I'm showing you the pin 5, the input to the TDA1022. And if you notice, it looks a little fuzzy, doesn't it? This, theoretically, should just be a sine wave, a pure sine wave, but it isn't. What it is, and I'm not even 100% certain on this, well, on how it works, but I definitely know it's taking the output of the 1022 and going back into the input. And what it's doing is sampling. So you're seeing little notches there. And in fact, let me show you the magazine article, and it's that right there. So that's essentially what's happening, and I'm getting it, which is good. And I know it's coming from the output because I can adjust things like the vibrato. That's the high, that's medium, and that's low. And you can see some changes even when I adjust some of the potentiometers here just to get different readings. You can see things are changing. So I clearly know it's coming back from the output to the input. Anyway, it's a good signal. Let's look at the output. All right, so this is where we test the output. So that's the output of the op amp, pin 6. Okay, so I'm showing the output, and it's going all over the place, which it's supposed to do, right? So I'll just adjust some controls. Yeah, so I mean, I don't even know what I'm doing. I have to actually listen to it to understand what's exactly happening, but it's clearly working. All right, so I think the next step is to put this thing in a case, and then I'll demonstrate it once, and that'll be it. Okay, so as you can see, it's done. and it still works, which is even better. So yeah, standard transformer and my power supply. So I have 6 other boards for a kind of a universal general power supply using voltage regulators. So that'll come in handy, I'm sure. And of course the main board. And yes, I know the wiring isn't the greatest. At least I got shielded cables for the input and output, right? Usually what happens is, you know, when I'm starting to, well, when I finish these things, it's usually on a Thursday or a Friday, and I just want to get the damn thing finished so I can upload it for Friday. I'll try to be better. And what else can I say? Well, it works. So let me put you on pause, and I'll set it up, and we'll go through the testing of this circuit. Okay, so it's the same setup as before. I've got the guitar amplifier as our driver for the speaker, and I've got a function generator feeding a sine wave to the device. And we're going to test the vibrato function. So let me just turn it on. Okay, so right off the bat, you can hear the vibrato. Now, this is the amplitude on the vibrato, so as I bring it down, you really can't hear the vibrato anymore, can you? So that's the amplitude of it. And remember, the vibrato is feeding, it's a low frequency oscillator feeding the XR2207. So it's acting, well, it's actually going to be modulated. Let me just go through some of the other controls. So we've got 3 ranges on the bottom, 0.3 to 1.3. And we have 0.9 to 2.8 hertz, and we've got 2.8 to 6 hertz. And here's the fine for the vibrato on each range. So works as advertised. Okay, let's move on to something else. Okay, so I think the best demonstration for the phasing is to actually play some music, because we're getting a lot of change in music, right? So let's play some music. All right, I think that was enough. So what I'm hearing, it's almost like an echo. That's what I'm kind of hearing. It's not the greatest. I think maybe if I had another TDA1022 in series with the very first one, we might hear a lot more of that echo sound. But it's definitely working. Yeah, gosh, don't know what to say. All right, let's move on to some more testing. Okay, one last test, and that's to test the external vibrato, the inputs that we have. We have 2. We have one for the, 100 millivolts or something like that, and then the other one for 1 to 2 volts. Well, we're going to use the lower version, and what that's going to do is it's going to cut out all of this. So it's going to cut out basically the low frequency oscillator that we've built in this circuit, and we're going to go directly into the XR2207. So right now I've got 1 hertz signal coming from a function generator up here, right here, and that's, like I said, feeding the input over here. So let me turn the amplifier on. And there's the 1 hertz. You can hear that. So let me just increase to 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see how high we can go. That's 100. And back to 3. All right. So I think that's enough, right? You've probably got bored to death at this point. Anyway, let's end the video, and I really appreciate you watching the video. And if you haven't subscribed or liked, please do that. I would appreciate it. And check out some of my other videos. I got a great one for next week. Bye for now.